Good afternoon, everybody, and thank you for taking the time out to link in today. We're joined by Danny Hemmings, Sales Director of Tranemo Workwear, to take a look at Arc Flash and how the hazard can be assessed and effectively managed. We'll also be touching on a case study with Aggregate Industries to look at the solutions which address their requirements. At the end of today's session, you will have the opportunity to pose any questions you have for Danny, or alternatively, you can send these over on the chat panel to the right of your screen, and we'll address those at the end of the session today. And I'll now hand you over to Danny.
Thank you for the introduction and also for the opportunity to just run through this session with your members. As Dave says, I'm the Sales Director for Tranemo Workwear in the UK and Ireland, and have been intrinsically involved with our Arc Flash and FR development program over the last 16 years. The idea of today is to give you a little bit of an introduction as to who we are. Some of you may have heard of us, some of you may not. And then to just look at the risk of Arc Flash generally, best ways to mitigate risk through correct usage of workwear and PPE. Touch on the case study, as Dave mentioned, the work we did with Aggregate Industries, go into a little bit of detail about sort of the steps to take in implementing an FR, an Arc Flash workwear and PPE program, and then, as mentioned, an opportunity at the end, some questions and answers. So without further ado, just a little bit about ourselves. Tranemo Workwear, Europe's leading manufacturer of inherent flame retardant and Arc Flash workwear. We've been a Swedish company. We've been manufacturing workwear since 1934, so we have a strong pedigree in terms of experience of making garments, technical garments, with a focus on innovation and functionality. But as we've developed our critical hazard workwear programs, really the focus towards zero flame and heat-related injuries. So as I said, we've over 85 years of experience in production, substantial group structure across Europe. We have 9 subsidiary offices, of which in the UK and Ireland, our office is based up at Cramlington in the northeast. Also quite unique as a manufacturer, we have our own production facilities in Europe. And I think most importantly, from a developmental point of view, all of our ranges come together in conjunction with looking at particular sector requirements, and then trying to solve those requirements, working in tandem with end users. So we work our solutions from the ground upwards rather than just from a product development internal focus, so that we make sure when we bring ranges to market that we know they're actually going to benefit the sectors that they're directed against. A selection there of some of our global customers, so operating across many different industry sectors, and have developed ranges that are particularly driven and geared towards the hazards present in some of those sectors. The common themes within those are, from our perspective, flame retardant protection and also Arc Flash. So there are commonalities across all industry sectors. And really our aim is to be seen as in the supply chain as the reliable, innovative experts developing the best workwear solutions using our expertise and innovative experience of manufacturing garments. The end goal being ultimately to be striving for zero serious flame and heat related work injuries. As I said, we touch across many different sectors. Obviously today we're focusing on quarrying, mining, minerals, that side, but large part of our business is in the energy utilities sector, metallurgy, infrastructure, engineering and maintenance, and also in petrochem as well. So if we look at the principles of Arc Flash, now Arc Flash, as some of you will well know, is quite a complicated area, and you can dig into it as deeply as you want to and spend a whole day going around and around in different facets of it. So really the aim of today is to try and sort of touch the core components, the core hazards that are present with the risk, and then work on as to how we can correctly mitigate against those. I think the important thing, and something certainly whenever we are talking and engaging with end users, is really pointing out that the hazard of electric arc is really nothing new. For as long as there's been electricity involved in industrial processes, really there's the risk of electric arc. I think what has changed particularly in the last 5 years, is the wherewithal to mitigate the risk and the injuries associated with electric arc. And they've really the wherewithal really has grown in an exponential way, particularly, I say, over the last 5 years. But if we look at the principles of an arc, I mean, really, in its simplest form, it's an explosion where there's a discharge of voltage and energy from electrical equipment. It's commonly caused when that current becomes uncontrolled and passes through an air gap between the relevant conductor points, so it jumps or arcs across. And in that process, there's a huge release of electrical energy that ionizes, and that creates large amounts of heat, light, sound, and pressure. Extremely high temperatures achieved at the core of the arc, but in milliseconds. So it's a big bang, big flash, and then it's kind of gone. And then the risk hazard associated with it very often is the cumulative effects post-arc flash. So understanding the different hazards and risks, yes, the flame element is a clear and understandable one in terms of the high temperatures that are generated at the start of the arc flash, which can ignite clothing. Obviously, can burn any exposed areas of skin. The same with the heat, convective and radiant heat transfer, which will cause second and third degree burn injuries. But there are other hazards that need to be understood as well. So whilst we can help protect from our perspective with clothing and PPE, there are other risks associated that have to take more of a holistic approach as well to the actual workplace. And some examples of that: molten metal splash, so metal debris, metal parts can liquefy or vaporize within an arc flash. Ignition risk of any nearby combustible materials post arc flash. Blast injuries to a worker from pressure and shock waves. Impact injuries from tools or loose objects that can be effectively projectiled from an arc flash. Also impact injuries from being effectively thrown into an immovable object, such as a wall behind where the operative is working. Noise, intense noise levels, so that can cause damage to hearing. Optical radiation, which can cause damage to the eyes. Respiratory hazards, which can come from the inhalation of toxic gas and also superheated air. So there's a whole host of hazards that go with being on the wrong end of an arc flash. Obviously, from our perspective, we focus on the holistic protection of the worker from a clothing and PPE point of view. And I think the biggest thing for everyone to really understand is we can never be at a point where arc flash is eliminated, because at its core, the issue with an arc flash is it's not a preordained event. So as we see there, in a percentage breakdown of arc flash incidents, over a quarter mistakes by the worker, a quarter material and equipment faults, a quarter a contact fault. So these are all things that really don't necessarily present themselves until the actual event happens. So elimination is, with elimination being at the forefront of the PPE pyramid, the problem with arc flash is that you can never really eliminate the potential risk for an arc flash. So mitigation is so important. When we talk principally about, from our perspective, the injuries associated with arc flash are based around thermal injuries. So these are burns to the body, second and third degree burns. Little pictogram there, which highlights distribution of thermal injuries. So the interesting thing you'll see there is that less than 10% of the injuries thermal injuries associated with an arc flash occur on the core body. And that's because most people will have clothing on of some sort, and also most people may have some clothing on that will either give flame retardancy protection or has flame retardant properties. So hence why in that core body area, the percentage of body burns is quite low. You then see it increases dramatically when you go to the areas of the body that are exposed. So principally the head and neck, and the forearms and the hands. Obviously the hands are the area that gets the highest percentage of thermal injuries, biased towards the right hand. Then you have lower arm, and that comes simply because of people wearing t-shirts or polo shirts, so not having lower arm protection. And then of course the neck and face and head area, people haven't got correct head protection on. So just quite an interesting pictogram there to see the spread of thermal injuries. This is a video that's generated by Westex, American fabric manufacturer. So that's a simulated arc flash on non-FR rated workwear. So this is a cotton with polyester content fabric. So you saw the big explosion. The arc is now gone. It's finished. The problem now is the fact that you have clothing that it's ignited in the initial arc flash. So in a very simple to understand video, you can see there the impact of not having correctly FR and arc rated garments on in the first place. By comparison, this is a test with a fabric that is FR and arc rated. Again, you see the same big bang, but now you see no ongoing ignition. There's no ignition to the garments, so we haven't created that problem of the wearer having garments that have now combusted and are on fire. Also, in slow motion, it kind of really gives you that visual representation of the amount of energy that gets released during an arc flash and the period of time it takes for that energy to release itself and dissipate. So when we look at the impact of thermal injuries, we're referring to first, second, and third degree burns, and to put that in some kind of context, you see there on the pictograms the cutaway of the skin layers. So as I'm sure you're probably aware of, the skin is made up of multiple different layers and is geared to protect itself to a certain degree. So for instance, if you apply a calorific rating to first, second, and third degree burns, when we talk about calorific rating, this is incident energy, and incident energy is measured in calories per centimetre squared. So if you look, for instance, at a first degree burn, and the most common first degree burn that we've all probably had at some point or other would be sunburn. And if you apply a rough incident energy to that, you're looking at approximately 3 calories per centimetre squared. It then doesn't need to rise too much to start to have second and consequently third degree burns, which become much more of an issue for the body to deal with. With a second degree burn, we look loosely at an incident energy around 5 calories per centimetre squared. In that, there will be damage to the skin, minimal or no scarring, and in an industrial environment or an environment where the body has been subjected to the incident energy, we generally look at 25% being the level at which above someone would require some kind of hospital or medical treatment. So generally, with a second degree burn, if the percentage on the body is lower than 25%, then the skin will regenerate and there shouldn't be any permanent scarring. Again, then there's not a huge jump to the incident energy required for a third degree burn, which we would look at loosely at 8 calories per centimetre squared. Here, you then have irreversible damage to layers within the skin, particularly the dermis and subcutaneous tissue below that. This now will destroy the nerves of the skin. That will lead to permanent scarring, no cell regeneration. And here, if we look at higher than a 50% body burn, a third degree burn, that is most likely to result in a fatal injury. So really, it's kind of the third degree burn level that is the most critical for us to try and mitigate against, because that is going to, third degree burns are going to be the life-changing, life-altering, and ultimately possibly life-threatening burns that we're trying to avoid. So looking then at the principles of what an arc flash is, we then need to try and understand the process of how we can mitigate that risk through the use of clothing and PPE. We then start to go towards the PPE directive and the different standards within European standards that we will use. And there's a selection there of the most common ones, and certainly the ones that we use predominantly in our garment ranges. There are a few things I want to cover today that will be quite new in terms of knowledge on electric arc. And the first one of those, you'll see there's 2 symbols relating to electric arc. There's the the symbol that's got the two triangles, one on top of the other, and then there's a symbol next to it which has a lightning strike going downwards with a pictogram of an explosion coming out from it. And this is really now the difference in the standards that we've been working to the standards that we're now going forward with, and in particular with regards to the new standard, that's IEC 61482-2 2018, which is a revised standard which we'll touch on shortly. When we look at garments and protection, you will, certainly with garments, you will have a multiple of those standards in there. And principally the fact that for a garment or workwear to give protection against electric arc, it must also be certified to the FR standard, which is the 11612 standard, which tests garments for different facets of flame retardant protection, both in terms of heat transfer and also in terms of ignition. The main thing we're trying to do with arc protective clothing is give that thermal protection to the core body areas. The focus being to reduce or eliminate the life-changing, life-threatening second or third degree body burns, as we touched on just before. So garments must meet the FR standard. Garments must also be certified to the electric arc standard, which is an IEC, IEC 61482. IEC stands for International Electrotechnical Commission, so they are the international body that have sat and created the standard specifically relating to electric arc. Again, it may be that garments need to meet other standards with regards to specific hazards. So, for instance, high visibility should be EN 20471 or anti-static EN 1149. Just depending on the workplace environment and the risks and hazards and applications that are involved. One of the things that as a manufacturer we always do is we will only work and develop inherent FR fabrics. When we talk about inherent fabrics, we talk about fabrics where the protection, the flame retardant protection is woven into the structure of the fabric. It's part of the intrinsic structure of the fabric, as opposed to a cheaper chemically treated FR solution where you take a cotton or cotton-rich fabric and you effectively immerse that or coat that with a chemical process. Whilst that's a cheaper way to create flame retardancy in a fabric, the problem is that those fabrics will degrade over use. They will degrade with washing. And the problem with that is that you are never quite sure as to the protection levels that are being offered over a period of time. Whereas with an inherent fabric, the protection is consistent through the lifespan of that product. So I think that's always a key thing to mention to people, is they should be looking for a solution that really comes from the use of inherent fabrics. The ARC standard itself, and this is where I think the principle of electric arc can be quite confusing, and the problem is the standard makes it even more confusing for people to get hold of. One of the things that the biggest area of that for confusion is the two test methods. So there are two test methods that are used within the electric arc standard. One of those test methods, which is called the box test, is a low voltage test that was developed in Germany and for quite a while became the standard format that European manufacturers would work to. The second test method, which is called open arc, works on a medium voltage range, and this gives a calorific value in the test data. And really the view with that is that is a better way to assess the protection of a fabric or the protection of a garment, because as we talked about before, you want to be referring to the calorific value, the incident energy in calories per centimeter squared. The problem with the box test is it's really very subjective. It's either fail class 1 or class 2, which makes it very difficult to create comparisons between product ranges or know really where you need to be from a protection point of view. To compound that to achieve class 2 in the box test, you really need to have a principle there of either 2 layers of fabric or 2 layers of fabric knitted together. So then you have solutions that become sometimes impractical, sometimes unworkable, too uncomfortable, maybe too expensive. So there were anomalies with regards to the box test. The problem was that the European standard or the European perspective couldn't encompass open arc as a solus solution because the open arc, the way that open arc data is presented works on a 50% probability of burn. And of course, the European standard won't countenance any probability or percentage probability of burn. So you kind of have a situation where the standard has merged so that it creates these two tests in tandem. So most garments, most manufacturers will work with putting garments through the box test and also putting garments through the open arc test. But it's widely recognized that open arc is better because it gives you an appropriate protection in calories, which in calories per centimeter squared, which means you can apply that to your arc rating requirements. The other things that the standard covers is things like fabric qualities, garment design, functionality of garments. So there are other things that go within the standard. And again, this is a video of the box test. So you can see a fairly rudimentary setup. This is designed to create a focused and direct arc going at the mannequin. And principally, as we see here, what we're looking for is no after flame, there's no ignition, there's no molten debris or anything. But as I said before, really, the only thing you'll come away with from this test is either fail, you achieve class 1, or you achieve class 2. If we look by comparison with the open arc method, here we have 3 panels with the fabric inserted onto the panels. There are sensors behind those panels. There are 7 shots that go through that panel. So that gives us, we're looking for a minimum of 20 readable values. They are then plotted into a graph, and that will give us this arc rating for a fabric based in calories per centimeter squared. So you can see there, just from the visual representation of the 2 different test methods, how they differ and how the open arc test results will give a much more rounded and a much more analytical format for protection values. I mentioned earlier about the changes within the revised IEC 61482.2 standard with regards to open arc test, and the fact that you couldn't adopt that in its entirety from a European perspective because of the situation of it being based on 50% probability for second-degree burns. What's now in force from the revised 61482 standard is what we call ELIM. And ELIM is slowly being incorporated and adopted into the user's program. And ELIM it works on exactly the same test methods, exactly the same process, exactly the same performance parameters that are then logged, but this works on 0% probability. So as opposed to 50% probability with the current system, where you would have what's called an ATPV, arc thermal performance value figure, or an EBT figure if the fabric itself is broken open at a particular energy level. That gives you a 50% probability. Now with ELIM, there'll be a 0% probability. And clearly what ELIM will do by virtue of that is bring down the levels of protection in calories per centimeter squared that a fabric or garment will offer. There's an example there at the bottom with a Tranemo winter jacket, flame retardant arc winter jacket, which currently has an ATPV rating of just over 40 cal. On ELIM, that's reduced to 34 cal. So it's not a like-for-like reduction. Even though we're going from 50% probability to 0% probability, you're, in that case, in that scenario, losing approximately 15%. But that reduction in 15% now gives you a 0% probability. In time, everything will move towards ELIM and 0% probability. The problem is that will mean a lot of people have to revisit and reassess their arc workwear program that they may have in place and make sure that the garments or the fabrics that they're using will be sufficient for the energy levels if they apply ELIM principle. So you can see what I'm saying, when you have a complicated process to start with, and then it gets complicated even further. And we see a lot of this when we engage with end users, that sometimes it's a question of people knowing that there's an issue that they have to address, but really not knowing the right steps to take and in which order to try and find that solution. The NFPA 70 American guidance also introduces what's called ARC protection zones, or sometimes called PPE categories, or just category 1, 2, 3, or 4. And this is designed to create the concept of safe working environments where there is an arc flash risk rated 1 to 4 based on levels of incident energy. Most areas we would see here would be within PPE category 2, which is the 8 to 25 cal risk. One thing we do say to people, and again, sometimes the misinformation in the market, is people will strive to get testing, particularly on layer testing, of higher and higher and higher calorific protection figures. Really, to put it in the real world, no one should be in a working environment where there is a recognized risk of over 40 calories, because that is a huge incident, and it's very remiss of any manufacturer to market solutions at 50, 60, 70 cal, because really that's an incident that no one wants to be involved in, because it will be like a bomb going off. So it's false protection to really take people above that threshold. And clearly there's a reason NFPA states that 40 cal should be the limit that's set. So, but 40 cal, it's a big incident, and it's quite a rare incident. And as I say, most of the time we will see users' requirements fit within the category 2, PP category 2, the 8 to 25 calorie range. There also, then, when you're trying to achieve protection, sometimes it may be that the protection offered by a single layer garment won't be enough for the incident energy that needs to be dealt with. So what we can do there is we can put clothing layers into combination, and therefore increase the protection that's offered, both the intrinsic FR protection, but also the protection offered in terms of resistance to thermal energy. And that's a question of, it's not 1 and 1 equals 2, it's 1 and 1 equals 3, because what you're creating between those protective layers is an air gap. And of course, air is a very poor conductor of heat. So an air gap in between 2 layers of fabric, or between 2 garment layers, will exponentially increase the protection higher, generally speaking, much higher than the sum of those 2 layers on their own. Also, you might need to use layering to provide other benefits. So, for instance, if working in a cold environment where you maybe need to use base layers, or of course, as we get most often in the UK, where we're using a secondary layer to protect against foul weather. So, for instance, rainwear, flame retardant rainwear. But it's vitally important, whether it's in a base layer or whether it's in an outer layer, that any garments that are worn in a layering system meet the same standards. The issue there is that if you introduce a layer that's non-complementary or incorrect fabrics, you can end up making a potential incident much, much worse. An example of that could be 100% polyester garment worn under a flame retardant arc jacket. The temperature or the thermal effects could still lead to that polyester underneath the outer layer burning or melting to the skin from the inside. Equally, if you wore just a standard high-vis jacket in an arc flash, that would just ignite and it would continue to burn, and the residue and the debris would stick to the workwear. So, of course, then it's compromising the protection that the workwear needs to offer in the first place. Again, this is a good example of that. So you have there, and this is garments that came from an actual incident in Scandinavia. You have one of our base layers there, which is a sweatshirt base layer, flame retardant arc garment, and the wearer put a 100% polyester fleece jacket over the top. So clearly not an FR rated or ARC rated product. You can see from the drop shot there, right side leaning in, and effectively it's destroyed all the fabric on the polyester fleece up the arm. As the arc flash has rolled, it's then gone across the shoulder and the upper chest and completely burnt away that outer layer. The fortunate thing, because our garment's done what it's supposed to do, is there's no ignition there, but you can see in the bigger picture there is charring to the shoulder area of our garment. And that charring is the result of burning residue being stuck to the base layer, which it's not designed for. So that graphically, I think, shows the benefit of why it's so important that any layer system must work in unison. We then go the other way and look at rainwear. You'll see on the left side, that's a post-arc test of a flame retardant arc jacket, rainwear jacket. So you can see charring from the explosion, but it stayed intact, clearly hasn't burnt. And you compare that to the image on the right, which is a standard high visibility rain jacket, no FR protection, no arc protection. And you can see that's most of the front of that garment is completely obliterated in the arc flash. And as that's obliterated, it will have turned into molten debris. And you can see there on the front of the mannequin that debris has stuck and burnt onto the base layer underneath. So vitally important that layers are complementary. And this just sort of summarizes we call it skin safe, our layering system. The idea being that your skin is your protection. That's where it starts. And then you put your layers in over the top. So layer 1 might be FR and underwear. Layer 2 might be an insulation layer for thermal protection against the cold. And then layer 3, your outer layer, will always be your primary FR arc shield. And in between all of those layers, as there's air that's introduced, that also increases the protection. One of the things we see extensively across the market, and this is sometimes always the way in a market that is rapidly educating itself in a relatively short period of time, is users sort of tick off the list, right? We're going to use these kind of garments that give us FR and arc protection. Great, we're all sorted, and miss the importance of arc protection with PPE. You remember back to the pictogram earlier of the distribution of thermal injuries. We know that the prevalence of life-changing, life-threatening injuries are to the hands, lower arm, and to the face and neck and head areas. So it seems kind of crazy that then a lot of users regard the job as done once they've put their workwear solution in place. It's so important to take a holistic approach to arc protection, protect the hands and face. There are plenty of options, plenty of ways that this can be done, and that's the really important parts of the body. They're the really important parts of the body to protect in an arc flash. The life-changing results, life-changing burns that we talk about, you can clearly understand that if someone's hands become badly burnt, that is going to have a massive effect on whether they can continue not only to do their job, but also to function with things that we take for granted every day with using our hands. Facial burns, massively life-changing every single day for the rest of someone's life. That is a reminder of the incident that they were involved in. So hands and face, absolutely critical to protect properly. And don't just kind of rely on the fact that you have standard PP. You have a visor or face protection or hand protection that is PP rated. That may not suffice. It's important that we're talking about PP and head protection that is arc rated, that has a protection level for thermal energy expressed in calories per centimeter squared. There's no excuse either now in terms of PPE solutions available. These are a range of the different options that we have within our portfolio. So really we can go through a completely holistic process from socks and belts up through underwear layers, up through the workwear layers, into outerwear, foul weather layers, hand protection, whether it's high dexterity required or more gauntlet protection, face visors, helmets with integrated visors, arc hoods, balaclavas, snoods. All these things are readily available so that we can create this whole body approach to protection. So we thought it would be quite useful, given obviously the forum that we have today, just to look very briefly at a case study that we undertook with Aggregate Industries. And that process started with a desire within Aggregate Industries to really look at creating a solution, a site and company-wide solution towards arc flash. So That took a variety of different stages. Firstly, it was, of course, identifying the arc flash risk within the business, but then the requirement to come up with a simple to understand matrix for the different types of arc risks that were within the business, and also the different types of incident energy that those arc risks may create. Of course, it's an aggressive working environment, so durable, functional workwear, absolutely paramount. It's no good ticking all the boxes for arc protection with a garment that's going to split at the seams after a couple of days usage. So you've got to combine the protection factor with durable and functional workwear solutions. Implement the protection for the hands and the face, as we just touched on. Most importantly, create the rollout program backed with education. The idea being that if you incept a system, particularly across quite a multi-estate business, it's very, very important to get worker buy-in. It's very, very important for it to be crystal clear why these changes are happening. Otherwise, we have the risk then of people not buying into it. They then won't follow the procedures, follow the protocols that are involved, and ultimately that could lead to someone being injured in an incident that they really didn't need to. And then the last part of the equation, of course, is integrating that with the supply chain, making it work. It's one thing sitting there in a fairly sterile environment and coming up with the solutions, but it's how those solutions get implemented, how those solutions get rolled out. So we sat down with AI and also the partners in the supply chain, being both commercial laundry that would deal with the laundry requirements for certain sites, and also the PPE distribution element to the channel. So the companies that are involved in getting solutions onto site and creating the sort of the basket and holistic approach towards protection, including things like tag out systems, lockout systems. But it was the original aim was to come up with the simplest possible layering matrix. We knew there were different risks within different sites and within different applications, so we wanted to make the simplest possible layering solution matrix that everyone could follow. We then went into multi-site product trials, engaged with user feedback forms so that we were able to see that if the solutions we were putting forward and we were deciding between us were the way to go, whether they were actually suitable in day-to-day application. As I say, working in partnership with ourselves, the PPE distribution channel, the commercial laundry, and Aggregate Industries. We then needed to create a measurement program. So that was on-site measurements for employees and key contractors to make sure that when the garments turned up, they were the correct size garments. And then going back to this buy-in process, creating a training module that every employee could run through, go through, understand why these changes were taking place. And that was done by creating an on-site guide for Arc Flash PPE usage, which had the matrix of AI within there, and then the different solutions for the different applications, together with care guides and visual inspection guides. That was generated within the business with content input from ourselves and also the other channel partners. We also worked together to create a video of that, which talked about correct wearing of garments, how to don garments correctly, what to look for in terms of inspection, and so on and so on. So a really comprehensive root and branch rollout of the solution off the back of finding the requirement and the needs in the first place of the hazards that were present within the business. I'm pleased to say that process ran through very well, and I think has been a significant positive process for AI in increasing the protection offered to their workers in the field of FR and arc flash risk. So if you're at that stage, some of you may be at that stage, some of you may be already on that journey, some of you may have already completed that journey, but in terms of how you implement an FR arc flash workwear and PPE program, what are the steps, what are the processes to go through? I think the important one there is the engagement not only with a manufacturer who understands the hazards that you'll have in your business, understands the hazards that are in your market, but will also have experience of how to deal and how to mitigate against those hazards. Certainly from our perspective, our job becomes very, very easy when there are arc flash assessments in place. Arc flash assessments will be assessments normally carried out by third parties where they will look at the areas where there's an arc flash risk and will calculate out through an assessment process the likely incident energy involved in an incident. I would say probably 5% of the people we engage with actually are able to produce arc flash assessments. Most of the time, the engagement comes as we're doing this, we appreciate we have an issue and we need to try and address that. And I think that's where our experience working in sectors becomes so important. So always look to engage with the manufacturer, even if that's the first step, engage with the manufacturer who understands your market and understands the hazards. And I think develop that supply chain relationship, develop that partnership approach, whoever the elements are in the channel, whether it be through PP, workwear distribution, or through an industrial laundry, have that engagement with the manufacturing partnership. That ensures you have their ongoing support. That ensures you have the ongoing review process. So the best solutions that work for us in the supply chain are when we sit together with channel, together with the end user, together, normally in a room, but in the last year on Teams, to make sure that everything is working as it should do in the supply chain. Dialogue with the workforce, vitally important. Remembering back to that was a big part of the process with AI. If you implement change without dialogue and without informing workforce, it becomes much, much harder to enforce that change. So we call it the 3 E's: engage, educate, and ensure. If we engage the workforce, we can then educate the workforce why these changes are happening, and then ensure that going forward, they know exactly what they need to wear, when they need to wear it, and how they need to wear it. And the whole purpose is to protect them at the end of the day. And again, we have modular training programs that can be adapted to any business to help with that process. Look for solutions that are inherent FR, arc fabrics, garments, properly rated, properly tested, and equally as important, arc-rated PPE. And kind of work to that goal that we work to, this zero harm from flame and heat related injuries. It's a nirvana goal, but it's a great goal to have, because just by having that and putting your processes in place for that will mean that most of the time, you should be successful in taking out that risk and reducing that risk, if not altogether, certainly massively reducing it. We've produced a very simple 12-page, I think it is, PDF catalogue on FR Arc Flash protection for the mining, minerals, aggregates and quarrying market. That's freely available from us. That will talk about some of the principles that I've spoken about during this presentation, and some of the practical garment solutions that we have within the sector. Which brings me to the end of my presentation. Thank you again for the opportunity to talk to you. I hope it's been informative. So you can find further details on our website, tranemo.co.uk, or by contacting our marketing team, marketing@tranemo.co.uk. But I maybe like to open the floor up then to any specific questions.
Hi, Danny. Clive Whittle here. Just a question. How resistant are the fire-resistant materials to the sort of conditions that mechanics and fitters and engineers contaminate the cloth with grease or oils that they're using in their normal work?
It's a very good question. And I think that, this is something that we see quite a lot in different sectors where contaminated garments, certainly if you contaminate garments with accelerants, then the flame retardancy protection can be compromised. The best way, to be fair, the best way of reducing that risk is using industrial laundry processes. That's not always a suitable solution, depending on location, but at least that way the garments are regularly cleaned professionally, but also inspected for any damage to the garments or any damage to particular areas. I think in the absence of being able to use a managed laundry program, the onus does come to the user and having a practice in place for maintenance of garments, whether that's self-wash or cleaning by some other means. But clearly, if it's a known accelerant that's going onto the surface of a garment and being ingrained into the garment, then attention has to be paid to the potential danger that accelerant will present in an incident. So.
Okay, thank you for that. And just another one: is there a warranted life cycle for the material to maintain its original fire retardancy?
If you use an inherent fabric, and this is kind of was my point about inherent against chemically treated, the structure of an inherent fabric is as it sounds. The flame retardancy protection element is an intrinsic woven part of the fabric as opposed to a treatment process. Therefore, as a rudimentary explanation, for as long as that garment is a wearable garment, then it will be offering the protection. Clearly, if a garment's been through 60, 70, 80 industrial washes, then as every garment will, fibers get reduced, fibers get torn and worn out, so the protection may not be as great. But really, generally speaking, garments won't get to that sort of lifespan. So the important thing there, as opposed to a chemically treated FR garment, is the protection won't diminish over time. In terms of a garment's sort of lifespan, that may be dictated, say, for instance, by high visibility standards. So the maximum number of washes that a garment can have based on the maximum number of washes, for instance, of the high visibility tape. That might restrict the lifespan of a product in use. But in terms of the intrinsic protection, the guarantee is that an inherent garment will be inherently FR through its lifespan, as opposed to reducing over time.
Thank you.
Okay, pleasure.
Hi, Danny.
Hi.
Hi there. As you said, you require buy-in for the guys to use this equipment. Mm-hmm. Is there a loss of dexterity when the electrician is actually using the gloves?
I think, again, this is the point I made in terms of the developments of not only clothing, but particularly ARC PPE for ARC PPE, probably over the last 2 or 3 years, to be fair, because dexterity and hand protection, of course, go hand in hand. If we look now at some of the hand protection that we have within our supporting ARC PPE range, the dexterity is exactly the same as a high dexterity non-FR, non-ARC glove, the widely used gloves that are on the market. It's not to say that you will always have ultimate dexterity, and again, that has to be looked at in isolation of the particular task and the particular environment. But generally speaking, certainly what we see in most of our engagement is the dexterity offered by the more sort of handling-based gloves, if you like, is exceptionally good. So.
Okay, thank you.
Okay.